keynote speaker, Professor Gonsalves, to share his thoughts with us. Over to you, sir.
All right, once again, a very good morning to everybody and start our presentation. So today I'm going to speak to you about outlining internal value system for AI. Okay, so outlining an internal value system for AI. This talk is going to be quite controversial with lots of things which you'll find disturbing. So I want the students to raise a number of questions at the end of this presentation. So we'll have three parts. The first part is how AI is used in practice. I'll mention three different fields where I've been using AI in my research. The next part, which is the core of today's presentation, we'll talk about the internal value system for AI. It's like a conscience for AI. And part three will be for questions. So AI in practice. This is our Sophia University, which is a Jesuit university. We have about 9 undergrad faculties and undergrad schools, about 40,000 schools. You can see that this is one of our old buildings. It's more than 100 years old, and the rest are new buildings here. So a small campus which has lots of old and new buildings in the middle of Tokyo. And this is my lab where we sort of do lots of AI computations and applications for business, for drones, for self-driving cars, for NLP, and for healthcare. You see here that this machine is a workstation which has multi-GPUs, which aids your computation, which speeds up the computation. We also make our machines because it's very expensive to buy ready-made machines. And these are some of my students. You see they look very happy here. You never see them so happy in classroom. This is because they finished their studies and they're graduating. So these are my two books, AI, Artificial Intelligence, a non-technical introduction. When I was a student, I was referring to an AI book which is called The Bible of AI. 99% of that book was mathematics, which is very discouraging. So I wrote my first book, which is not technical. You will not find a single formula in that. So it's easy even for art students to read and understand. The next book is about the AI for business. So these books are available on the internet and they are selling like hotcakes. So make sure you buy a copy and get them signed by the author down here. All right. So let's see. A question to the students. How many of you think that this is an AI? Please raise your hand. Nobody? How many of you think this is AI? I think all of you are right. This is not AI. Why? Because each and every instruction, what the robot is doing is programmed inside. So it cannot do more than what it is programmed. Okay? So this is not AI. What about this? This is a robot who can play a violin much better than a human professional. This was invented by Honda some years ago. Is this AI? It plays music better than human beings. What do you think? How many of you say this is AI? Nobody. I think students have to be shy. Okay. Now again, this also is not AI because each note on the musical score, the style of bowing, the pause, the expression of music, all that is pre-programmed. The very fine movements of the fingers. So because it cannot play things which are not already programmed inside. So in short, if a program cannot do more than what it is programmed for, it is not supposed to be AI. Right? Fine. You know the structure of a computer. You have hardware. You have OS, firmware. On top, you have application So AI is just an application program to see here. So it's not a robot. So many people think that AI is necessarily a robot. But AI program is a piece of software. It need not be. It need not be. It need not be hardware. It need not be robotics. It's a very small application program. So there's no need to be afraid of AI. If most people are afraid of AI, they think it's a black box. They don't know how to behave or to do. So AI is not a robot. It is not a black box. It's a very small application program which resides on top of all the computing layers. Okay? And this is how we define AI. In fact, this definition was given about 70 years ago in 1950. The science of building machines or computer programs that can think and behave like human beings, or intelligent computer programs. So these programs may or may not be embodied in robots, may not have a physical body. Now, why do you think we want to make machines which are as good as human beings? It's not to replace human beings, but to help us to solve our social problems. So AI started in 1950, but it took us almost about 45 years to have the first successful AI program which could beat a human champion in chess. And then you had the quiz competition, which was where the humans lost to AI. And in 2016, you had the famous Korean, Japanese, and Chinese game of Go, which is considered to be the most difficult board game. So AlphaGo was an AI system which won against human champions. Okay? So it took us more than 70, 80 years to develop AI which could win over human beings. Okay? So this is because for a long time, researchers did not know what intelligence was. Right? So now in 1990, for the first time in the AI world, intelligence was defined as the ability to learn and solve problems. And this learning which is done in AI is totally different from human learning. So in AI, machine learning is defined as finding patterns in data and making predictions. So I'm sure all of you know this. But learning does not mean remembering things in AI, but it means finding patterns in data and making predictions. Okay? So these three are the pillars of AI. You have lots of data, you have programs, and you have processes. Okay? If you remove any of these, our AI will collapse and will not be able to go further. I'll just cut short to the history of AI because most of you know this. Now, the latest in AI is something called deep learning. I'm sure you know this, where we use a neural network, which is kind of a resemblance to the human brain. Now, how do we human beings, as children, how do we learn? How do we identify and recognize objects? So somebody tells us, when we look at a picture, somebody tells us this is an orange, this is an apple, or this is a pineapple. So there's a label given to each object, which our parents, which our teachers tell us. And we try to identify these objects. When we usually look at these objects or touch them, a network is created inside our brain. There are certain neurons which are firing, certain neurons are very inactive. So this they form a network corresponding to an object. And this is how we do not remember a particular object, but we remember its appearance, its color, its taste, its size, its shape. It forms a pattern in our brain. Now, this is exactly what deep learning programs do. Sorry. This is called a deep neural network, as you know, which is a very poor imitation of the human brain. So, if you put your data inside here, all these neurons, this try to identify the patterns which are found in this data and predict what the data is all about, whether it's an apple or an orange, or if the email is spam or hacked, it can sort of identify and recognize. Okay, so that's how AI will used in deep learning, because we kind of sort of use this neural network to solve different problems. And this same structure could be used to identify text, pictures, speech, and so on and so forth. Okay. So we're going to, now next part is about the applications. In my research, my students in my lab, I've been using AI for education, for transportation, and for healthcare. So let me briefly explain these three areas before we go to the problems which current AI has produced in our society. Okay, at Sophia University, we have a very famous program which is called the Content and Language Integrated Learning. That means you learn the language not just by learning the grammar rules, but start the contents. Start the contents. Try to, as a student, try to express. Let's say if you're doing physics or engineering, you try to learn it in a different language altogether. So you're learning the content. Now we use lots of AI programs to sort of teach our students. So each student has an AI teacher which can adjust the learning to the individual needs of the student. We also made this Spanish grammar error correction system. That means our teachers would relax a little bit. Our AI system would sort of read the essays of students who learn Spanish and try to correct automatically. So this was very successful until about 3 years ago. So after ChatGPT gave it the picture, I think we lost business. So now we are not using the system because ChatGPT is slightly better than us. Okay. So as students, I'm sure you have used AI as tools for education. You can have there are lots of platforms. There's automatic grading for teachers. There are study aids. There are chatbots. There are smart content creations. There are NLP programs, and even computer programming. The last item here, you can even get your programs made by ChatGPT. So in education, AI has helped us very much. Okay? But associated with this, there are also problems about which we'll talk later. The next technology, which I've been very much involved in at least for about 10 years in my lab, is self-driving cars. It's also called autonomous driving, where we have a car driving all by itself. There's no need for a human driver, so that it is very safe, very efficient, and very comfortable when it comes to driving. So when we made this lab in 2019, this was the layout which was designed so that all our small cars, miniature cars, could move on the floor. We could put signals. We had a 3D printer where we could sort of print signals, road signs, road markings, and our cars would drive inside. Unfortunately, I don't have a video because I forgot to get them on. Okay. So this area, the floor was used for our autonomous driving. Now, why would we need autonomous driving, self-driving cars? The first issue is safety. According to our statistics, about 3,700 lives are lost on streets every day. Now, this is a reality. 3,700 people die every day on the streets because humans are not very good in driving. Humans get distracted. Humans are very careless. They're not very careful when they drive. So if you leave this to machines, if you really program them well, if you make them learn how to drive on a very large scale, we expect the machines to be better than humans in driving. So that's the first reason. Next, we have problems like congestion, pollution, parking space, lack of comfort, cost. All this is because of our current technology. So we try to overcome all these problems through autonomous driving. So this is what we expect the cars to be in the future. On the left-hand side, we have the conventional car, where you have the steering, and you have the control, you have the brakes and accelerators. So in the future, we expect our cars to be like a theater, where you don't have steering wheels, you don't have gas pedals, you don't have brakes, because it's all electric, the car will drive by itself, and the passengers, they can watch a movie, they can listen to music, they can do their work on the way to office. So this is how in Japan and in the United States we already have cars which are offering lots of comfortable rides. I'll show you a short video where self-driving taxis will be used in Tokyo for next year.
不審な車がいたりすると、その時は運転手さんちょっとやってましたけども、ほとんど自動で、すごいなと思いました。
Okay, so if you see this video, it's pretty old because we're expecting the technology to be on the streets for the 2020 Tokyo Olympics, but because of the pandemic, we couldn't do all that. All right, so the next field where I've been working with my students, this is very recent, is AI in medicine. So as you know, there are lots of areas where we can use AI for medicine. Like first of all, we can do diagnosis and prescription from text data or from medical images, your X-rays, your CT scans. All those images could be used to identify if there's a problem with a patient, whether it's drug discovery, personalized medications. All of us now, if we are sick, we take a pill or we take some medicine. Now, if we give the same medicine to everybody, which is not very good because sometimes it doesn't suit different people. So this personalized medication requires that AI will find out at the molecular level which kind of medicine fits a given individual. Number four, we have AI for patient care, where we can use different programs or robots to take care of old people and even to acquire into mental health and to do some counseling. All this technology is being used the world over. So in short, so this is how you would use AI. Most of the students I'm sure know how deep learning is being used. This is how AI can be used in medicine, which is actually being used. First of all, you have input system. Okay, so the medical staff they input the patient's data into AI programs. It could be the different medical tests, it could be different symptoms which the patient is complaining about. The AI system sort of diagnoses, finds out what is wrong, finds the patterns, and make predictions. The AI systems make predictions based on this patient data. So that's all what we said was machine learning was all about. And so, but that's not the end of. You do not leave everything in the hands of AI. Doctors refer to these predictions in diagnosis and treatment. They refer to the advice given by AI programs, and they use the expertise and experience to diagnose and to do the treatment. So this is how AI is used. Next is personalized treatment, which I just explained to you. Not giving the same pill to everybody, but looking at individual needs, the individual body composition, the genetic heritage, and accordingly adjust the kind of drugs that a person should be given. AI in drug discovery. Now, this was greatly used during the pandemic to find a vaccine. Right? So we'll have to go, as you heard from one of our distinguished speakers this morning, how the molecules have been discovered which could fit this virus and sort of destroy it. Okay. Recently, we have lots of robots used in caregiving in Japan because we have a shortage of nurses, doctors, and personnel, so we use robots to aid the medical staff. Okay. And these are some of the functions which AI-powered robots in hospitals and healthcare facilities. They're assisting with surgery, they're delivering medications, they're doing physiotherapy, they provide companionship to patients. There are robots who can listen to your complaints. The robots can do counseling at some stage, not perfectly. So they can even attend to mental health and counseling problems to some stage. Now this robot called Robear, it's like a teddy bear, is very famous in Japan. It can lift patients. As you know, in Japan, daily bath is like a ritual. They have lots of hot springs. It's not just a shower. People like to get into a hot pot. So it's very difficult to lift the patients. Imagine a nurse trying to lift a 70 kg person and put it in the bath. That would be very difficult. The nurse will break her back. So we use robots to carry patients very gently and sort of giving them a bath. Okay, so this is one of the applications. All right, so that's all for the time being. I'll just try to summarize some kind of applications that we have done in three different fields: my education, and transportation, and healthcare. Okay. The second part, we will see All that we have seen so far are the advantages of using AI, the benefits, the good things. But in the second part, we will see that there are lots of problems. There are lots of social, there are lots of ethical problems. And how are we going to address these problems? So the answer is we are addressing these problems by creating an internal value system for AI. To describe this thing very briefly, how do we human beings identify what is good and what is bad? Because we have been trained in that. We have kind of an internal value system. We have internalized the values which is given to us by our parents, by our school, by our teachers. So all of us have the so-called conscience, which enables us to distinguish between what is good and what is bad. And accordingly, we make use, we rely on our conscience every time when we have to think, decide, and act. So can we have something similar for an AI before it makes a decision? Can it have kind of an internal value system on which it can base its decisions? Okay? So just to give an example of this, I'm sure the students have heard about Tay. Tay was a teenage girl with a chatbot created to interact youngsters through tweets. Okay? About 16, 17 age American teenage girls, they were supposed to teach Tay about their lives, about fashions, about schooling, about sports, about music, about dance, about everything. Unfortunately, they realized that in just half a day's time, they had learned offensive language and hate speech. Just half a day's time. It would not do any good greeting. It would just be bad words. Now, why did this happen? Because you have this famous saying, in AI garbage in and garbage out. All the teenagers had taught this day bad things, foul language, bad words, dirty language, hate speech. And that's how this robot, this chatbot, had learned only bad things. Could not utter a single good expression, single good word. Okay? So this is what is happening with AI today. Whatever you put in comes out on the other side. So if you put in good things, you will get good things out. If you put in bad things, you will get bad things out. Garbage in, garbage. Now, why does this happen? Obviously, because AI has no internal system where it can judge for itself if something which is fed inside is good, or which is something is fed inside is bad. So whatever is put inside, it just finds out the patterns and gives us predictions. So it has no way of learning something that is good or bad. So I think one of the things we need to decide from now on is to put some kind of an internal value system in the program so that the programs understand what is good, what is bad. Okay. So this is, I'm sure, as software, in your software class, in your AI class, in your machine class, everybody is doing this. How do we do machine learning? First of all, we have data sets available free of charge. We download them, we try to pre-process, we try to filter out all the noise, and trim the data, trim the images, make them sort of suitable for the input, and then we sort of train them with the model. The model is a program, and then we test it. And what we do is we get predictions, right? Everybody knows how. Now the problem is, when you look at the predictions, sometimes the predictions are biased. Sometimes they're tainted. The program is not transparent. The program cannot explain why it makes certain predictions in favor of some people, or this kind of a gender bias or a race bias. And the whole of AI is not responsible, it's not accountable. So all these problems are being pointed out in today's deep learning models, right? And why does this happen? Just because AI does not have an internal system which can judge for itself whether the decisions or the predictions are right or wrong. Okay? So in short, in its current form, AI does not have the least idea of ethics, just like human beings. We human beings, we have knowledge, we also have ethics, we have a value system. So we know how to use our knowledge based on some ethics, based on some value system, which is given to us by religion, culture, education, society, so on and so forth. Okay, so now if you see, if you read lots of papers, newspapers, magazines, there's a lot of talk on AI ethics in UNESCO. So the world needs stronger ethical rules for AI. Programmers, researchers should take into consideration value systems, ethics, before they develop their AI systems. There are lots of AI regulations. The European Union, for instance, the United States, Canada. I'm not sure about India, but most of the countries have started making very strict rules and regulations about the privacy of data and about transparency in the algorithms that we use for machine learning. So in short, if we look at the current state of AI, we have explained that there's a lot of problem of lack of transparency. It's called inexplainability. That means the data, there is data bias, algorithmic bias, lack of transparency, unaccountability. But I think we can solve this problem in the future. If you have nice filters, if you know how to filter your biases in your data, if you can design transparent algorithms, there's a lot of research in this area. So this is a technical problem. It's not so much an ethical problem because the data sets we're using are not really balanced. They're not good. They have lots of problems. So if you start our machine learning with good data, data which is not biased, data which is not sort of bad, we can somehow, or algorithms which are very transparent, somehow we can at least try to mitigate, reduce the problems caused due to inexplainability. So we need some more time, maybe another 10 years or so. The second point, which I see in AI, is called malignancy. That means if AI falls in bad hands, like you can have AI wars, you can make weapons, you can make so many bad things, which can destroy humanity. Now, there are lots of books on something called AI singularity. I'm sure you know this word, singularity. Is what happens at the center of a black hole. A black hole in astrophysics is a star which has collapsed, and it is so strong, the gravity is so strong that the light cannot escape from the surface. So that nobody knows what happens at the center of a black hole. Physics, mathematics, all our sciences cannot describe what happens inside a black hole. So that's called a singularity, something which is very, very frightening. So there are lots of books which try to explain if AI continues to develop by itself, it may end up into singularity. That means we human beings will not be able to control it anymore. We will not know what it will do by itself. It could destroy humanity. It could do so many bad things. Okay. Now again, I think this is not a big problem. This is more like a science fiction movie. Okay, so we need not worry about it. Maybe in the future, not at least in my lifetime. Okay. So right now the problem that I see is the third one, which is called disruptions. The humans are thrown out of the loop. AI is trying to dominate center stage, and we humans are being sidelined. And I think this is a big problem with current AI. And this needs to be addressed by all of us, by AI researchers, by our students, by everybody who is developing AI. Okay? So remember the word disruption and humans out of the loop. So how are we going to handle this problem? Right? So I like to imagine AI as like a huge dragon. It's a dangerous beast. It's a very powerful beast, which feeds on tons and tons of data. As I told you, we cannot have AI, we cannot have machine learning without data. So we need volumes, big data, volumes of data. So this dragon, which is like AI, is eating lots of data, and it tries to do some type of blind processing. It is not aware what it is. It's just blindly processing using some computational and mathematical algorithms. So the processing does not have any guidance system. It's very blind. And the dragon, by fluttering his wings, is kind of giving us predictions, which sometimes are biased and very wild. They are not, it doesn't have a value system. For some people they are good, and some people they are bad. So trying to put rules and regulations on this dragon is like building a wall outside. So this is not solving the entire problem. It's just solving part of the problem. Remember, imagine you have a ferocious dog at home. Okay? You're trying to keep the dog on a leash all the time. So the dog behaves as long as it is on a leash. But if it happens to escape from the leash, what will happen? It will go and bite people. So this is what's going to happen with AI. Also, if you try to control it externally with our rules and regulations, it will be fine. But the minute somebody so disobeys rules and regulations, AI will be out of control. So this solves our problem partially. So how are we going to solve this problem totally? So before we go to this solution, let's talk about technology in general. About 200 years ago, as you know, there was something called industrial revolutions. That means earlier on, we used to do all our farming, agriculture, using our hands. Actually go to the fields, dig by ourselves, plant, and sort of cultivate and do the harvesting. That was replaced overnight by tractors, by machines. Okay? Next, our transportation was like a horse carriages, or humans would walk from place to place. That was replaced by cars. Even household works was replaced by lots of machines. So what has happened here? The industrial revolution has brought automation, has made life automatic with the machinery, which has displaced human activity. Now, according to Karl Marx, who is a great economist, man is a working animal. He or she has to work with their hands. So we bring in lots of creativity and value and meaning to our life through our hands as we work, as we design something, as we do something. Okay, so activity is something very, very central to our lives. Now this is being displaced by industrial revolution, and this had happened about 200 years ago. Today we have another revolution, which is called the AI revolution. And what is this AI revolution doing? Now we human beings are very good at thinking. All our education is meant for us to make us think to solve a problem. So if humans are given a problem, humans will think about the problem and try to solve it. Okay. Now this AI revolution has brought in autonomy. We just talked about autonomous cars which can drive by themselves. They can make decisions whether to stop, to go left, to go right, to proceed. Okay. We have chess programs. We have programs which all have autonomy when they play against human beings. They can make their own decisions. They can decide for them. So that's called autonomy. So remember these two words: automation and autonomy. Automation is just mechanical things, making things ready-made, but they don't have autonomy. Autonomy is when programs, and these are intelligent programs, can decide for themselves. Okay? They can decide. They can think. Okay? So the AI revolution, by introducing autonomy, have displaced human thinking. So in short, if you look at these two revolutions, which have taken place within 200 years, human beings are thrown out of the loop. So humans were at the center about 200 years ago, as far as the activity and thinking was concerned. Now, the automation brought by industrial revolution displaced human activities. The human is on the loop now. Activity need not. You can sit, watch your television the whole night. The machines will do all work for you, mechanically. So that's called automation. And now with AI, we have this autonomy brought by AI revolution, which displaced human thinking. So now you can see the humans are out of the loop. This is the biggest disruption. We are nowhere. We are not in the center stage as far as our thinking and activity is concerned. I just explained to you about autonomous driving. In fact, internationally, there are 6 different levels, from 0 to 5. The first 3 levels are very mechanical. That means you have lots of AI systems which assist you in driving, helps you, like back mirrors, parking, lane keeping, automatic brakes. So the first 3 levels is called AI assisted driving. If you see on top, the human being is always in charge of driving. It's the responsibility of the human being to drive safely without crashing, without meeting with accidents. But when you go to level 3, 4, 5, the highest levels are 4 and 5, where there's no human being. Drivers are out of the loop. The AI system does the full control in all situations, highways, in crowded streets, there are signals, without signals. Okay? So now, if you see, this whole technology is designed to keep humans out of the loop. Because humans, as we have said earlier, are supposed to be bad drivers, dangerous drivers. They kill 3,700 people every day. Okay, so the effect is we have good sight, we have lots of good driving safety, but humans have no say in driving. Humans are thrown out of the loop. And you can see that this happens not just in transportation. It could happen in each and every domain, in each and every sector that humans are thrown off the loop. And this has created a big disruption. So let's talk about education. All of us, most of our students, we are using lots of chatbots and generative AI to write the reports, to write the programs. Fine. So we have accessibility to lots of information. Fine. Everybody gets information just with a click of a button, which is good. We also have personalized learning. You can go to a personalized learning AI, learn a new language, learn a program, which is good. But on the other side, there are lots of negatives which are not seen. Okay? There's lots of misinformation, hallucinations. AI produces books, references which don't exist at all. They provide information which is false. So the humans, especially our students, have no way of knowing if the information is right or wrong. We go down day by day in our critical thinking, which is essential in all forms of education. And the bond between student teacher is decreasing day by day. I think the last element, the teacher student bond, is extremely important in all forms of learning. In Japan, we have the traditional arts like tea ceremony, there's Aikido, there's karate, there is Ikebana. All these arts, you cannot learn them from the books. You cannot learn from AI. You have to be constantly in touch with the master. It's the master who is shaping you. In a similar way, in our Indian situation, we have the Guru Shishya tradition, if you remember, where the Guru is guiding you all the time. You learn not so much from books, but you learn things like the spiritual wisdom, yoga. You always learn from the Guru. It's the Guru who is shaping you. So in a similar way, in our education, the classroom is a teacher who's all the time trying to shape you, not just giving you knowledge, trying to shape your personality. Now this is going down day by day, the student-teacher bond, and which affects our student very badly, so that the character formation no longer exists in our classroom. So if you see, there are more negatives than positives to AI in education. In transportation also, okay, if you have self-driving cars, they'll be safe, there'll be less accidents, there'll be increased mobility. Anybody just can call a Uber taxi in the middle of the night and everything's okay. But the negatives are, if there's a breach in security, the whole system will crash. Okay? What happens in emergencies? Let's say the passenger suddenly falls sick. What will the car do? Or if the car is in an accident, whose responsibility? So we have lots of problems when it comes to emergencies. The ethical dilemmas. Okay, there is something called the problem with trolley. So if the car has to brake, will it hit the people outside or will it try to save the people inside? So lots of ethical dilemmas, which somehow we human beings try to solve using our conscience. So will AI be able to solve this? So, towards the end of our talk today, we try to propose some solutions to these problems. Okay, so this is going to be the last part of my talk. So please pay attention because I'll have lots of questions to the students based on this. Just keep it. As we said earlier, if you put garbage in, you get garbage out. This is because there's no internal system AI which can judge if something is good or bad. Let's look at the human conscience on the right-hand side. When we make decisions, or when we decide that something is right or wrong, there are three different elements. First of all, we have knowledge. There's an ethical code inside us, which we have learned right from our childhood. There's experience, okay? And there's empathy. Empathy is a feeling for others, feeling towards people. So can we make this kind of modules in AI? Can we do something like knowledge, ethical knowledge for AI programs? Can we replicate experience in AI? And can we have something called empathy for AI? So let's just look into these three concepts because this is something very, very new and I've not seen this anywhere. So these are my proposals for creating an internal system for AI. So once again, we make ethical decisions based on knowledge. And this knowledge is acquired from religion, culture, education, common sense, so on and so forth. Okay? So knowledge is something which is codified in the form of text, which you can make a knowledge base, just like a database, given all the rules and regulations to behave itself. But this can be done. We already have expert systems which function based on human knowledge. So in a similar way, we can build AI knowledge systems which can act based on this technical knowledge. Now, what's experience? Experience is the knowledge acquired after repeated trials of success failures. Okay? As children, we have been taught by our parents and our teachers how to behave, but we make mistakes. We make mistakes, but we learn from our mistakes. Okay? Or sometimes we're successful. We try to repeat this successes. So experience is something which we learn. It's also kind of a knowledge which is acquired through practice, repeated practice. And empathy is positive feelings towards others. Now what happens is, when we have to decide something, first of all we think whether it is right or wrong. Second, we count our experience, or in the past I've faced similar situations. Sometimes knowledge and experience are not enough. They're not enough when we have to decide, especially in medical situations. Okay? To save the life of a patient, what to do. So that's the time we fall back on something called empathy, a system of feelings where we feel for the person. Right? And most of our difficult decisions are based on this empathy. Okay? So can we design an AI system which will have knowledge, experience, and empathy? That's the question. The research question in AI. Okay. So I think yes. Knowledge, yes, we have done this. About 30 years ago, we had expert systems which could perfectly imitate human knowledge in any given domain, especially in medicine. Experience, yes, we have fuzzy systems. If you have learned fuzzy logic in your classes, you know how to design a fuzzy system which can deal with imprecise, uncertain knowledge and experience. Okay? Now the third part is not yet done. How do you create machines which have empathy, which can understand empathy? And the new branch of AI, which is trying to address this problem, is called affective computing. Okay? So this is the latest, which I'm doing with my students in Tokyo. Affective computing is a new branch of AI, which aims to develop systems that can recognize, interpret, and respond to human emotions. So please remember this. What's affective computing? It's a new branch of AI that aims to develop systems that can recognize, interpret, and respond to human emotions. The emotional part. So far, there is no emotional part in AI, but we need this for ethical decisions. So can we train our AI systems to understand human emotions? Okay? And this is what my students have done, undergrad students. Try to understand human emotions just looking at the face. Photograph. If the person is smiling, maybe he's happy. If the person is quiet, maybe the person is sad. If the person is disgusted, you can see it on the face. If the person is angry and annoyed, you can see on the facial expression. ECG spectrograms from this signals, you can identify the corresponding emotion. Maybe the person is excited, maybe the person is angry, maybe the person is relaxed. Also speech. We express lots of our emotions through our speech. When a person is happy, you can see the speech changes, becomes very warm. If the person is sad, you can see the tone changes, it becomes very sad. If the person is angry, you can see the pitch rises. Right? So we can analyze speech of a human person at a given point of time and pinpoint to the kind of emotion that the person is trying to express through his or her speech. Okay? So now this is called a multimodal analysis. That means we take into consideration not just one mode, but more than one mode of expressing human emotions at one time. Maybe look at the face of what the person is saying to his face. At the same time, try to take in all the physiological functions, the sensors, like the ECG, the pulse, the heart rate, the amount of perspiration, those could be monitored to the sensor, okay, real-time monitoring, and of course the speech, analyze the speech in real time. So if you can combine all these different modes of analysis, you can more or less figure out what the human being is trying to say, kind of expression, and you can develop kind of empathy. Okay? So this has been done by my, unfortunately couldn't send a paper to this conference, but at least we have 4 or 5 papers in the making about this how to recognize emotions. Okay, so I think if we sort of have these are the 3 major problems that we currently have: AI, inexplainability, malignance, and disruptions. So if we try to sort of develop a conscious internal value system for AI, it will try to solve our inexplainability. It will strive for fairness and explainability because now it has internal conscience. It will strive to mitigate harm and risks. So even if AI falls in bad hands, if bad humans give it wrong commands, it will say no. This is unethical. This is not okay. Disruption. It will try to keep humans in the loop. Okay? Let's say in a medical setup, AI will not decide everything. There are certain things when it comes to life and death decisions. AI will say, okay, this is my limitation. Please refer to the expert doctor. So this is how AI will try to keep humans in the loop when it comes to important decision making. Right? Now, if we succeed in doing this, explainability, malignance, and disruption, we will have AI, the dragon in the heart, with an internal conscience, a value system, just like the human being, so that, of course, it will continue to feed on data, but now the circle will be complete. You'll have external rules and regulation, which is given to us by governments, by the governing bodies, about privacy, about explainability, about rules and regulation, but it will also have an internal conscience, so that, feeding on data, it will have a value-based process. So if you don't have a heart, your processing becomes very blind. But if you have a heart, it becomes value-based. And finally, we hope that we'll have reasonable predictions without gender bias, without race bias, which is fair to everybody. So if we have an AI with an ethical sense, we will try to solve these disruption problems. So let's say on the positive side, in education, if you have an AI with conscience, how will it behave? It will try to guide our students to achieve the true ideal of education. So if a student is copying and pasting all the time from ChatGPT, AI will say, hey, look, you are cheating. You're not getting educated. Okay? Go and refer to your teacher. If you're doing all the assignments and homeworks by just using AI, well, you may get good marks in your education, your exams, but you're not learning anything. You'll suffer in the long term. So now this is a value-based system which our AI will tell our students. Okay? This is what I'm aiming at. So that in the long run, we'll have more positives and negatives. In a similar way, we can it will make our students more aware, and it will tighten the bond between teachers and our students. We can talk of similar balance which is stored in self-driving vehicles. When a car is driving, if there's an emergency, the car will always refer to human beings. How do we decide now? There's a patient who is sick in the car. What do we do? Okay, take him to the hospital. Okay. So if there's a crisis, the car will stop and always refer to human being to make decisions. So this is how we try to mitigate the disruption which is brought by AI by keeping humans in the loop. Thank you. So that's the end of my talk, and we'll just take some time for questions. Thank you very much. As I said earlier, this is very controversial, and I expect the students to raise lots of questions.